Okay, so for this first one, here's an example that should help you. So if A is acceleration, V is velocity, and X is position, and then I'm giving you these things, that the acceleration at any time t is 12t, the velocity at 0 is 7, the position at 0 is 2, I'm asking you to find the position at 8. So what you need to know is that acceleration is the derivative of velocity, and velocity is the derivative of position. So we know the acceleration function, so we really have to go backwards twice, so antiderivative twice. And the way that I'm going to recommend you do it is with the antiderivative as an integral formula. So, okay, so I'm just going to write it here. So, all right, so going backwards, so I can say that v of t is v of something we know, so v of 0, plus the integral from 0 to t, and then this is going to be 12w dw. Okay, so then we have that v of t is equal to, so v of 0 is 7, plus, so I'm going to use the fundamental theorem here. So this is 6w squared. And then, so v of t is equal to 7 plus 6t squared. Plus 0. Okay, it'd be minus 0. So you don't even need that. All right, so the velocity at any time t is 6t squared plus 7. All right, you could have done that without using the antiderivative as an integral formula, but I'm going to use it as much as I can because it is so helpful. There's so many problems on the AP test that you can't do without it. So I'm going to use it like whenever I can, just so that we're in the habit of using it. It always works. Whenever you want an antiderivative, it always works. It's, you know how like the quadratic formula will always work. The antiderivative with an integral formula always works. Okay, so now I want x of 8. All right, so let me find x of t first. So I've got x of t is equal to x of 0, because that's what we have, plus the integral from 0 to t, 6w squared plus 7dw. Okay. All right, so this is x of t is equal to, this is 2 plus the integral from 0 to t, 6w squared plus 7dw. And then I'll go x of 8 equals 2 plus the integral from 0 to 8, 6w squared plus 7dw. Okay, so I'm going to move over here because I'm running out of room. So this is 2 plus, okay, so here's 0, there's 8. So I need the antiderivative of this, so that'd be 2w to the third. 2w to the third plus 7w. All right. Oh, shoot. I picked a big number that I can't do. All right, well, so this is 8 to the third plus 7 times 8 minus 0. Which this, I know that this is a no calculator section, but they wouldn't give you a number like this on a no calculator section, I don't think. 2 times 8 to the third. I mean, I can do it, but it just will take a while. And you could do it too, but it would just take a while. Oh, yeah. So this is, okay, so this is x of 0 is that. So that's the position at time 0. Okay, this next one, you can do it. You need the left-hand limit to equal the right-hand limit. This next one, I'm going to do this whole thing with you. All right, so what you need to do is you need to be looking at number 3 in your no calculator section, okay? All right, and I'm going to read the problem. Okay, so the graph of the function f shown above consists of 3 line segments. And so you should be looking at this at the same time as I'm reading it. If the function g, unless you're at home, I'm sorry. If the function g is an antiderivative of f such that g of 2 equals 5, for how many values of c, where c is between 0 and 6, does g of c equal 3? Okay. Okay. Well, here's the thing, guys. All right, so I'm going to use the U try section. Okay. We know g of x is continuous because it's an antiderivative. Guys, if something is an antiderivative, it must be continuous because you couldn't have taken its derivative if it wasn't continuous. So any function that is differentiable is, first of all, continuous. So you know that it's continuous. Okay? Okay. All right, so that's what we know first of all. All right. So, secondly, we could say that g of x is equal to g of 2 plus the integral from 2 to x of g prime of w. All right, that's the antiderivative with an integral formula. It always works in every situation. But guys, g prime of w, that's f. Okay, so we can say g of x is equal to g of 2 plus the integral from 2 to x, or actually, g of 2 we know is, we know what that is. That is 5. And then this is f of w dw. Okay. So this is g of x. So they want to know for, okay, so how many times within does g of some number equal 3? Okay, that is the question. Well, guys, here is the thing. Okay, all right, I'm going to do like a weird sort of table. So this is a version of the candidates test up here. And when I teach you the theorems that we're going to have to know, this is going to be helpful. All right, so let me come up with a name for this. Candidates test. Never mind. Okay, I can't come up with it. Okay, so this is sort of like the candidates test. Candidates test. Okay, but I'm going to do it in a strange way. All right, so I'm going to go like this. I'm going to say, okay, so this is going to be x, and this is going to be g of x. Okay? Now, the endpoints are going to come first. So I'm going to have an endpoint. The first endpoint is 0. All right? But then I'm going to skip, I'm going to like skip a space right here. Okay? And then the first critical number, this is where f, g prime is equal to 0 or is undefined. So that would be 2. All right, and then I'm going to skip a space. And then the next critical number is 5. Okay, and then I'm going to skip a space and then 6. Okay? All right, now the reason I do this is because there are values between here. All right, there are values like between 0 and 2. There are infinitely many x values that give us a corresponding y value. And same between 2 and 5. There's infinitely many inputs that give us a corresponding output. Between 5 and 6, infinitely many, and no gaps either. This is a continuous function. All right, so let's just see if this works for us. I wish I made these bigger, actually. Okay, so for this, it's going to be, okay, so g of 0 equals 5 plus the integral from 2 to 0, and then this is of f. Okay, I'm not using proper notation because I don't have a lot of room. Okay, and what is this equal to? Well, guys, I'm not showing it to you, but you should be looking at your paper. The integral, so this is going to be 5 plus, okay, the integral from 2 to 0, that's a backwards interval, so that's going to be a negative number. And it's a triangle, so it's 1/2 base times height, so it's 1/2 2 times 2, so it's just 2. So it's 7, all right? Now for 2, g of 2 equals 5 plus the integral from 2 to 2 of f equals, well, guys, if you're, this is a 0 length interval from 2 to 2, so that integral is 0, so this is just 5. That is, oh, that should be -2, whoopsie, that's -2, because it was a backwards interval, my bad. All right, so that should be 3. Okay, so guys, already we have 1. All right, so there's one value where it's 3. Okay, and then, so, all right, so there's that, that's 5. And now g of 5 equals 5 plus the integral from 2 to 5 of f. Okay, so from 2 to 5, that is a triangle. So 1/2 base times height, and it's negative. It's a negative area, so that's 5 minus 3 equals 2. All right, and now 6. G of 6 equals the integral from 2 to 6 f equals 5 plus, okay, so that's -3, okay, plus that other triangle is 2, so that's -1. Okay, now here's the thing. This is a continuous function. And guys, with the candidates test, these are all of the possible maxes and mins, all right? So what happens here is that, you know, this y value is 3, and then the function increases till it hits 5, and then it decreases till it hits 2, and then it increases till it hits 4. If it's a continuous function and the y values decrease from 5 to 2, it must reach 3 between here. It must reach 3 somewhere between here. Okay, so these are like C values. C values, C values. All right, and then again, between 2 and 4, so it starts at 2, this interval, you know, the y value start at 2, and then we increase, and go to 4. So again, must reach 3 between here, okay? Yeah, so guys, we've got 1, 2, 3. All right, so there are 3, what does it ask? For how many values of C does g of C equals 3? The answer is 3. So the answer is D, right there. Okay. Now this next one. Guys, you can do this. Just remember that e to the 20th is a number, so its derivative is 0, and same with 3e. Okay, so here is the next one. Let y equals f of x be a twice differentiable function such that f of 0 equals 1. What is... And a lot of you didn't know what this was. This is just the second derivative. It's Leibniz notation for the second derivative. Okay, so what is this? So, I don't know, maybe d, I don't even know how you'd say that. I would say the second derivative of y with respect to x. But if you're reading it literally, you'd say like d squared y over dx squared, I guess. But it means y double prime. It's the same thing. So what is the value of the second derivative at x equals 0 if the first derivative is this? Okay. So guys, this is, that's y prime. All right, so you could be like, so y prime equals this. So y double prime equals 2y y prime plus 4y prime. You've got to do implicit differentiation here. Okay, and then when you're finding the second derivative with implicit differentiation, where I have these y primes, I'm just going to plug that back in. So this is y double prime equals 2y times y squared plus 4y plus 4y squared plus 4y. Okay, and now they want, so they want they want the second derivative. Okay, and this is notation. This means evaluated at x equals 0. Okay. But guys, if you look at our second derivative, there's no x's in there. We don't have any x values. We only have y's. So we could say this. We could say, well, this is equal to the second derivative evaluated at the point that has 0 as an x coordinate, and they gave it to us at the beginning. So 0, 1. Okay, and that's equal to, I'm just plugging 1 in for all the y's. So this is 2 times 1 squared plus 4 times 5. That ends up being, so this is 2 times 5 plus 4 times 5, which is equal to 20, 30. Okay, number 6, you can absolutely do this. You need chain rule. The inside is going to be g of x and the outside will be f of blank. Okay, so here is this next one. Let y equals f of x be the particular solution to this differential equation with initial condition f of 1 equals 3. Find y equals f of x. Okay, so the first thing you do is you separate the variable. So I'm basically like cross multiplying. So we've got y dy equals x plus 3 dx. Okay, then you take the antiderivative. It's important that you have these integral signs. I don't think they'll give you full credit if you don't for notation. All right, so this here, this is going to be 1/2 y squared equals 1/2 x squared plus 3x plus c. That plus c is important. Okay, then what we've got to do is we've got to find c. Okay, so I would find c first, and then we'll solve for y. All right, so this is, so we've got f of 1 equals 3. So that's the x value, that's the y value. That's our initial condition. So 1/2 3 squared equals 1/2 1 squared plus 3 plus c. So this is 9/2 equals 1/2 plus 3 plus c. And then we get c is equal to, so you subtract 1/2 and you get 8/2. So that becomes 4. And then you subtract 3. So you get that c equals 1. Okay, so this is 1/2 y squared equals 1/2 x squared plus 3x plus 1. And then we've got to solve for y because, guys, here they say find y equals f of x. This means they want us to solve for y, or express y as a function of x. So I'm going to multiply both sides of this equation by 2. So this is y squared equals x squared plus 6x plus 2. And then y is equal to plus or minus radical x squared plus 6x plus 2. Now here's the tricky part. You can't have two equations. Okay, the plus and the minus, those are two separate functions. And together they're not a function at all because it wouldn't pass the vertical line test. So the question is it the positive or the negative function? And that's when you look at your initial condition, okay? Okay, so initial condition gives positive output. So y is the positive one, all right? So it's going to be the positive one. So the answer is that y is equal to radical x squared plus 6x plus 2. So at the very end of these problems, when you're deciding if it's the positive or negative choice, it's the one, you look at the initial condition and see whether that output is positive or negative. Okie dokie, this one, you can absolutely do that. Okay, this I'm just going to give you some tips. Look for points where the slope is 0. Okay, so you're looking for horizontal segments. Plug the x and y coordinates of these points into this and see if you get 0. Use process of elimination. Really, guys, that's the way to do that. Okay, so let me write this, though. Another way. Okay. If dy dx equals 0, then x squared plus y equals 0, which means that y equals negative x squared, okay? All right, so what you would be looking for, okay, so y equals negative x squared looks like this. All right. And what they're telling you is that for these points, for the points that satisfy this equation, you're going to have a 0 slope at those points. So if you looked at the differential equation, it would be like, it would look like this. Okay, actually, let me do this. At all of these points, like at this point, you'd have a 0 slope. At this point, you'd have a 0 slope. At this point, you'd have a 0 slope. At this point, 0 slope. This point, 0 slope. You see what I'm saying? Like, at all of these points, you'd have 0 slopes. So if you could pick out a pattern of horizontal segments that are in this form, then you will be able to see it. That is another way. That's a little bit more sophisticated, and I feel like harder for people to remember. So that's why I didn't go with it first. But that's actually how I did the problem. So you're looking for something like this if you use that. Okay.